Hi, I'm Patrick. This is Matt, and together we built an automated hardware-based image perspective correction system. You can see here that we have a camera, the NTSC camera, pointed at an object on the desk. What our project does is it takes a picture of this, and then based on that picture, it'll actually apply mathematical transformations to display a rectangular object as if we were looking at it head-on, instead of an angle like this.
So the system tries to automatically find the corners of the rectangular object, and it does this by applying a canny edge detection to the image. So it calculates the gradient in the image and the luminosity of the image, and it tries to find areas of large gradient in the luminosity, and it counts these as edges in the image. Then it takes these points, and using a Hough transform, it tries to find long edges in the image that would represent the corners of the rectangle, and using these corners it can perform a transformation on the image to produce an output version of the image, which is a direct view of the rectangular document. So now I'm going to demonstrate the automatic corner detection system. So the first thing it does is take the original image and apply a 5x5 Gaussian kernel to the image and make it into black and white. So here you can see a slightly blurred version of the original image. It then takes this image and applies a canny edge detection. A canny edge detection to the image, and it attempts to highlight the edge pixels in purple, as seen here. So you can see the outline roughly of the student ID. And then from these pixels, it attempts to calculate a Hough transform, where it tries to find which lines are strongest in the image. However, this can't really be visualized very well, so I can't really show that. It did work quite well, however, the system struggled to find which lines were best. Due to the fact that these lines are quite thick, it would often find parallel lines in the image, and then from that you couldn't find the corners of the student ID.
So here we have 4 corners of a rectangular object identified. These were done using the manual interface. It might be kind of hard to see, but the corners appear as crosshair-shaped sprites on the location where we think the corners are. And they're different colors, so you can identify which one's top left, which one's lower left, etc. Now, if I tell this thing, okay, I'm satisfied with the corners, and I advance it, it produces a transformed version of my student ID here. So that even though this is taken at a pretty shallow angle, it still displays the student ID as if I were looking at it straight on as a rectangle.